Welcome to the solution of ISI M.Math 2024 question based on abstract algebra. So today we are discussing the subject section PMB. PMB. Okay. There were two questions from the abstract algebra, one from group theory, another from ring theory. The first question was from group theory, and the question is saying that H be a normal subgroup of G such that there exists a homomorphism G H which takes each H to H, and we need to prove that G is isomorphic to G cross G over H. Okay, we need to prove that these two groups are isomorphic. Now, to prove these two groups are isomorphic, we need to define a mapping from G to the product of these two groups. Now, let us define a mapping. Let if such that G to H cross G over H defined by f of small g equal to, observe that I need to write two components, and before to write this component, this second one is quite easy, that is the induced quotient g by gh. But what would be the first component of you also need to understand that I need to write an element of I need to write an element of h, but this g is an element of g. So by how I can define a mapping? To define this mapping, I need to use another mapping or another homomorphism, which is pi. Pi takes each element of g to the element of h. So the mapping would be pi of g. Okay, so this is an well-defined mapping. Now I need to prove that this f is the isomorphism from G to H cross G over H. The first three parts of being homomorphism and injective is quite easy, but there is a trick behind proving it onto mapping. Now let me show you that. So let G1, G2 belongs to G. Then f of G1, G2. This is nothing but pi of G1, G2, comma G1, G2, H. G1, G2, H. Now I can write it as pi is also homomorphism that can be defined write as pi of G1 composition pi of G2, and this G1, G2, H can be write as G1H, G2H. So that can be written as pi of G1, comma G1H, pi of G2, comma G2H. Now, so this is equal to f of G1 and this is equal to f of G2. So I have proved that this f is a homomorphism from G H cross G over H. Now I am done with the homomorphism part. Now I need to prove that this pi is a bijection between them. Now to show this pi is a bijection, first I need to prove that this pi is an injective mapping. Now to prove that this f is an injective mapping. Now to prove that this f is an injective mapping, I need to prove card of f is equal to the identity element. So let us choose an element. Let A belongs to card of f. So I can write that f of A is the identity element of this group, and identity element of this group is equal to the identity element of H, which is E, and the identity element of G over H, that is H. Now f of A, what is the image of f of A? F of A is equal to pi of A, comma AH. This is equal to E, comma H. Now these two are same. What does this mean? It means pi of A is equal to E and AH is equal to H. Now AH is equal to H implies A belongs to H. We know that this is a very well-known result in quotients. So now as A belongs to H, now observe that the definition of pi takes each H to H, where now as A belongs to H, so I can write pi of A, this is equal to A. Now see what is pi of A. Pi of A equal to E. So I can write A equal to E. So whenever an element A belongs to kernel of F, that becomes the identity element. So I can write car F is equal to the identity element E, and hence this mapping F is injective. So I am done with the one-to-one part. Now I need to prove this mapping is onto. Now to prove that this mapping is onto, what I need to do, let me show you. There is a trick behind proving it an onto mapping. Now to prove it is an onto mapping, let us choose an arbitrary element h from h cross g over h. That a h comma gh belongs to h cross g over h. Now there are two cases. Now let us write the first case when this g belongs to h, and there is be another case where g is not belongs to h. Now when this g is belongs to h, I can write gh is equal to h. So this element h comma gh becomes h comma capital H. As in this case I have considered g belongs to h. Now so this implies, let us find out the image of f of h, the value of f of h, that is equal to pi of h comma h of h. That becomes pi of h comma h. So in that case this small h is the preimage of the element h comma gh when g belongs to h. Now let us consider another case when g not belongs to h, or g is not in h. Case 2. Now in that case, now as g doesn't belong to it, but observe that by definition of this mapping pi, I can say pi of g belongs to h. Now what is the value of pi square g? Pi square g is pi of pi g, right? Now as pi g belongs to h, observe that pi g belongs to h, and each element of pi of h is equal to h for all h belongs to h. This implies in place of pi of pi g, I can write pi g. As, let me explain it again. Let us consider that pi g equal to h, that belongs to, as this is an element of h. So pi square g is equal to pi of pi g. But observe that I have considered this pi g as h, so that becomes pi of h. Now as pi is a mapping where each element of h goes to h, so that goes to h, which is equal to pi h, right? So pi h is an element of z. Pi g is an element of h such that pi square of g is equal to pi g. We know that any element of a group where h squared is equal to a is nothing but the identity element. So therefore it becomes pi g is equal to the identity element e. Hence, I can say that whenever g is not in H, then the value of pi g is equal to the identity element of H. Whenever g doesn't belongs to H, pi g is the identity element of H, which is also the identity element of G. Now, so in that case, let us try to find out the value of f of Hg. F of Hg is equal to pi of Hg, comma Hg capital H. So this is equal to, as pi is a homomorphism, that would become pi of h, pi of g, comma h, h, g, h. So that can be written as pi of h goes to h and pi of g is the identity element into pi of h is h, gh. So by definition of quotient, I can write this is equal to h, comma, gh. And hence pi of, in that case, pi of g, hg is the preimage of the given element. And hence this mapping F is the isomorphism, and hence G is isomorphic to H cross G over H. One more thing you need to observe that H is normal in G. This condition used just to show the existence of G over H, nowhere else. Now, let us move to the next question. Now, this question is from the ring theory.